Uh, so this one, these are not going to cancel each other out no matter what, right? They don't cancel each other out. But it's actually a way of restating a problem that we've already kind of solved before. I mean, what this is saying is, and this is the way I read it to myself, right? What is the tangent when the cosine equals 2/3? Right? We did problems like that like 2 sections ago where it would say, if cosine theta equals 2/3 in quadrant 1 or quadrant 2, then find tan theta. Right? That we had problems that we already did that, and that's all that's saying. Right? Why do we say only quadrants 1 and 2? Because that's where we look for the cosine inverse. Right? We only look in quadrants 1 and 2. So if the cosine equals positive 2/3, which quadrant is it? Is it quadrant 1 or is it quadrant 2? It's 1, right? If it's a positive, so I know that when I draw my picture, and I should draw my picture, I'm going to draw it with the triangle in the first quadrant. The theta is with the x-axis. Right. Now, if the cosine is 2/3, I can label 2 out of those 3 sides. Cosine is adjacent over hypotenuse. And then I need to find the third side, which I will find by doing second Pythagorean theorem. Right. So this side will be the square root of 3 squared minus 2 squared, which is the square root of 5. Right. At that point, I've got all 3 sides on the triangle. I can answer the question, what's the tangent? Which is square root of 5 over 2. So it's really identical to those problems that we did before. They tell you the value of the trig function. They give you another clue so you know which quadrant that you're in. Right? Because it's these inverse functions, we don't need another clue. We know which quadrants we're looking in for all of those.